Hello and welcome. Ever wonder what happens after a big cyber attack? You know how digital detectives actually solve the crime? Well, today we're opening up the casebook on network forensics to see exactly how they piece together the story of an attack, one digital clue at a time.
Yeah, that's the big question, isn't it? When a system gets breached, it's not just about cleaning up the mess, it's about figuring out exactly what happened, how it happened, and who was behind it. So, let's try and solve this mystery together.
You know, every single investigation starts with just one moment, an alarm, a little signal that says something isn't right on the network. This is basically the first phone call our digital detective gets.
So this detective work, it has an official name, network forensics, and it's all built on this really simple but powerful idea. Every single action on a network leaves a trace. The whole goal is to find those traces and just follow them all the way back to the source. So what's our detective actually looking for? Well, first, the how, the exact path the attacker took to get inside. Second, the what, the specific tools and tricks they used. And finally, the evidence, all those little digital breadcrumbs they left behind that can be used to build a solid case.
The very first clues are called indicators of compromise, or IOCs for short. The best way to think of these is like a digital fingerprint or a footprint left at a crime scene. It's that clear, undeniable signal that a system has been touched by something malicious.
And what do these clues actually look like in the wild? Well, it could be a computer in your office that all of a sudden starts trying to send data to a server in a country you've never done business with. Or maybe a user account that only works 9 to 5 is suddenly logging in at 3 a.m. These are the kinds of red flags that kick off a full-blown investigation. Now, our detective can work in one of two ways. Post-mortem analysis is that classic detective work, right? The crime has already happened, and you're meticulously piecing together the timeline. But real-time analysis, that's more like being on a SWAT team. The intrusion is happening right now, and the main goal is to stop the attacker before they can do any more damage. All right, so the alarm's been raised. Now it's time to secure the digital crime scene and really start looking for that hard evidence. This is where the detective starts following the digital trail the intruder left behind. And the very first place to look is in the network logs. You can think of these as your eyewitnesses. DHCP logs tell you which device had which IP address at a certain time, basically who was at the scene of the crime. DNS logs, they can show you if a computer tried to connect to a known criminal hideout online. And firewall logs, well, they're like the security guard's notebook, listing everyone who tried to get in and whether they succeeded. But here's the catch. These logs can have millions, even billions of entries. So how on earth do you find that one crucial clue? Well, investigators use some simple but incredibly powerful command line tools. Think of grep as a superpowered searchlight, find as a map to navigate the entire file system, and tail as a way to watch events unfold as they happen. And just look at how powerful these tools can be. With a single, simple command just like this one, an investigator can instantly pull every single line containing a suspect's IP address from a massive log file. I mean, this is literally how they find the needle in the digital haystack. Okay, so looking at log files is kind of like reading notes about what happened. But what if you could actually watch a replay of the attack itself? Well, the next level of forensics lets you do exactly that. This is done through something called packet sniffing, and the concept is actually pretty simple. You basically set up a digital security camera on the network that records every single piece of data, every packet that flows through it, and that gives you a perfect, pristine recording of everything that happened. And the tools of the trade here are, well, they're legendary. Wireshark gives you this amazing visual window into all that captured traffic, letting investigators dissect conversations packet by packet. And then you have TCP dump, which is the real workhorse, a command line tool that just reliably captures all that raw data so you can analyze it later. So having all these packets is one thing, but making sense of them? That's a whole other challenge. Session reconstruction is the magic that turns this chaotic mess of raw data back into something that makes sense, like the exact web page an attacker visited or the file they downloaded. And one of Wireshark's most amazing features makes this incredibly easy. With just a single click on Follow TCP Stream, an investigator can take a completely jumbled conversation and see it perfectly put back together. You can see chat logs, commands, even stolen data, exactly as it was sent across the wire. It's so cool. So we've got logs from dozens of different systems, we've got raw packet captures, and this actually creates a whole new problem: information overload. How does an investigator connect all these different pieces of evidence to see the full story of what happened? Well, that's where a SIEM comes in. A security information and event management tool is basically the mission control center for our digital detective. It pulls in evidence from every source you can imagine, firewalls, servers, applications, and puts it all together on one screen. A SIEM really does three main things. First, it collects and manages all those logs in one central place. Then, it monitors all that data for threats in real time. And most importantly, it correlates events to connect the dots and generate alerts that actually mean something.
An event correlation, well, that's the real brain of the whole operation. It's the process of finding the signal in all that noise. It can see a failed login on one server, a new file created on another, and an unusual data transfer a second later, and it understands that those three small, seemingly unrelated things are actually one big, significant security incident.
So how does it work? Well, it's a pretty smart three-step process. First, it normalizes all the data, which just means it makes sure all the logs are speaking the same language. Then it aggregates similar events together to cut down on the noise. And finally, it filters out all the routine, boring stuff, letting the detective focus only on what's truly suspicious. Okay, so far, we've pretty much focused on traditional wired networks. But our digital detective also has to investigate modern crime scenes, like, the air itself. Let's take a look at how these same principles apply to wireless networks. A classic wireless attack is called the Evil Twin, and it's basically a fake Wi-Fi hotspot designed to trick you. As you can see here, the fake network name, the SSID, it looks exactly the same. But the BSSID, which is the unique hardware address of the access point, that will be different. It's kind of like spotting an imposter because their fingerprint doesn't match. An investigator can spot this difference in a second.
And all this brings us to a final thought. Network forensics is really the art of watching the network to catch the bad guys. But in a world where our personal data is flowing across countless networks every single day, it raises a pretty critical question for all of us. Who's watching out for our digital trail?